Okay, so now our next chapter is calculus. Now this is the most important chapter from engineering mathematics from GATE point of view, and probably it is the longest chapter in all our 8 chapters. So here we will start with some of the basic concepts. So first we'll learn how to draw graph of some of basic functions. So the first graph that we need to learn is graph of this function y equals to mx. M is any real number. Okay, so we all know that this graph is a straight line passing through origin, but we'll see what happens when for different value of m. So let me first plot these two lines. These are our coordinate axis. This line is x axis and this is our y axis. Now we all know that equation of this x axis is y equals to 0. So this means when m is 0, we will get this line x axis. Okay. Now suppose if m is 1, then we all know that this will be our y equals to x line, making an angle 45 degree with x axis. Okay, so here the value of m is 1 for this particular line. I'm simply writing the slope here. So the slope of this line m, this will be 1. Now as you increase the value of m, suppose if you have another line whose slope is 2, then this line will be something like this. Okay, this will be your line with a slope 2. Similarly, suppose if slope is say 1 by 2, then it will be a line on this side of y equals to x line. This will be your line with slope m equals to 1 by 2. So as you can see that as you increase the value of slope, here slope is 1 by 2, then 1, then 2. So as you increase the slope, the line will move away from this x axis and towards this y axis. For x axis, the slope will be 0, and for a line which is very close to y axis, the slope will be approaching to infinity. So for x axis 0 slope, for y axis infinity slope, and as this slope is increased, the line will move away from x axis and towards this y axis. Okay, in this direction slope m is increasing. Okay, another important point, whenever slope is positive, then in that case your line will be in first and third quadrant. Okay, if the slope of line is increasing, then you can see that our line is in first and third quadrant. And if the slope is negative, then in that case, for example, this will be our line y equals to minus x. Here the slope will be minus 1. So now your line is in second and fourth quadrant, right? And again, as you increase the magnitude of slope, the line will move towards y axis. For this particular line, the slope will be minus 2. If you have a line on this side, then for this particular line, the slope will be minus 1 by 2. So as you can see that as the slope of this line is increased, then as the magnitude of slope is increased, okay, here magnitude of slope is 1 by 2, here magnitude is 1, here it is 2. So in this direction also, this magnitude of slope mod m is increasing. Okay, so for a line close to this x-axis, slope will be 0, and as we move away from the x-axis and towards the y-axis, the slope of line, the magnitude of slope will be increasing. So this is all about our line y equals to mx. It will always be a straight line passing through origin. If slope is positive, then we'll have a line in first and third quadrant. If slope is negative, then we'll have a line in second and fourth quadrant. So this was our first graph. The second one is graph of y equals to x to the power n. N is any positive integer. Now here we have two different cases. The first case is when n is odd number. Okay, if n is odd number, then how to draw the graph of this function. All these are very important concept, and we'll see that once you learn how to draw graph of different type of function, then this chapter will become very easily. Simply by seeing the function, you can tell whether the function is continuous or not, differentiable or not, what are the point of maxima and minima. So all those things you can see if you know how to draw the graph of a given function. So these are some of the standard function whose graph you must know. So here first case we are going to see how to draw the graph of y equals to x to the power n when n is any odd number, meaning that how to draw the graph of this function y equals to x, y equals to x cube, y equals to x to the power 5, and so on. So I am not going to tell you how these graphs are obtained. The graphs are obtained by taking different value of x, finding their corresponding value of y, plotting those points in coordinate plane, and then joining all those points. But here we will learn how to draw the graph of this type of function. So for y equals to x, this will be simply a straight line passing through origin. This will be your line y equals to x. Now next is this graph of y equals to x cube. So the graph of y equals to x cube will be, the nature will be something like this. It will start from minus infinity, third quadrant. When x is minus infinity, y will be minus infinity, and as x is increased, the value of y will increase. It will cross this line at this particular point, minus 1, minus 1. You can see that this will be the point of these two curves. Minus 1 is lying on both of these curves. It is on y equals to x line, and it is also on the curve y equals to x cube. So this will be the point of intersection of these two curves. Then again these two will meet at origin, because when x is 0, then from both of these equations you will get y equals to 0, and after this you will get a curve something like this. This point of intersection will be 1, 1. Okay, so this is your graph of y equals to x cube. This will be the nature of graph of y equals to x cube. The nature of x 5, simply I am writing x here. It is implied that this x cube, these are nothing but value of y. So this will be our graph of y equals to x cube. Nature of x to the power 5, this will be similar to x cube, except that before minus 1, graph of x to the power 5 will be below x cube. Then minus 1 to 0, it will be above. 0 to 1, again it will be below this. And so this will be your graph of y equals to x to the power 5. Okay, this one is graph of y equals to x cube. Then you have this graph of y equals to x to the power 5. Let me take different colors to represent this graph. So first one is this, our line y equals to x line. This is represented by this blue straight line. Then we have this graph of x cube, which is drawn by this black color, and then we have this graph of y equals to x to the power 5. Okay, this is our graph of y equals to x to the power 5. So the nature, important thing here to learn is that the nature of all these graphs, x cube, x to the power 5, x to the power 7, all these graphs will have similar nature. Only thing is that between minus 1 to 0, x5 is more than x cube, and between 0 to 1, again x5 is less than x cube. Okay, here this one is x to the power 5, x cube, and this is y equals to x to the power 9, x to the power 1. Now another important thing that you need to know is, suppose if you want to plot the graph of y equals to say x to the power 1 by 3 or graph of x to the power 1 by 5. So for drawing these graphs, the first step will be draw graph of y equals to x cube. Okay, and then take image of this graph x cube in this line y equals to x. Meaning that if I want the graph of this function y equals to x to the power 1 by 3, then this will be nothing but image of this x cube in this line y equals to x. So the graph will be, if you take the image of this black line in blue line, then you will get a curve something like this. Okay, and similarly here also on negative side, if you take the image of this black graph in this blue straight line, then you will get a curve something like this. So this will be your graph of y equals to x to the power 1 by 3. Similarly, suppose if you want to draw the graph of x to the power 1 by 5, then now you need to take the image of this graph in this y equals to x line. So now you will get a graph something like this. Okay, this will be your graph of y equals to x to the power 1 by 5. Now for explaining the concept, I have drawn this graph that x to the power 1 by 5 is below x to the power 1 by 3, but always remember that this will be always increasing function. Okay, in this graph you might think that this x to the power 5 is decreasing, but that is not true. This graph of y equals to x to the power 5, this is always increasing, because in this equation, as you increase the value of x, the value of y is going to increase. Okay, so this is how we draw the graph of y equals to x to the power n when n is odd number. Okay, these were the graph of x cube, x to the power 5 and so on. And we also learned how to draw the graph of this x to the power 1 by 3, 1 by 5 and so on. Now we will see how to draw the graph of x to the power n when n is even number. Okay, next we have to see how to draw the graph of this function y equals to x to the power n when n is even number, meaning that we have to learn the graph of y equals to x square, x to the power 4, x to the power 6 and so on, y equals to x to the power 6 and so on. So again all these graphs will have similar nature. Suppose if these are our coordinate axis, this line is our x-axis and this is our y-axis, then first thing in all these functions you can see you have even power of x. So this means whatever be the value of x, the value of y is always going to be positive, right? Even if you have some negative value of x, y will be a positive number and y is positive in first and second quadrant. So this means no portion of graph will be in third and fourth quadrant. Now we all know that this graph y equals to x square is an upward parabola, right? This is your graph of y equals to x to the power 2. Okay, this was our graph of y equals to x square. Now suppose if we want to draw the graph of this y equals to x to the power 4, then again these two graphs x square and x to the power 4, these two will have similar nature, except that suppose if this point is say x minus 1 y plus 1 and here this point is x plus 1 y plus 1, then graph of x to the power 4 will be something like this. Okay, this will be the graph of this function y equals to x to the power 4. Okay, this is your graph of y equals to x to the power 4. And you can see that why this is correct, because when you have a number between 0 to 1, okay, if the number magnitude of number is less than 1, then in that case x to the power 4 will be less than x square. Okay, for example here suppose if x is 1 by 2, then on the graph of x square you will have y equals to 1 by 4, whereas on the graph of y equals to x to the power 4 you will have 0.1 by 16. So obviously this 1 by 16 is less than 1 by 4. Okay, so between minus 1 to plus 1 x to the power 4, okay, you can write this thing when x is from minus 1 to plus 1, then x to the power 4 is less than x square. Okay, x to the power 4 is not always more than x square. If the number is between minus 1 to plus 1, then x to the power 4 will be less than x square and therefore this will be the graph of x to the power 4. Now similarly if you want to see the graph of x to the power 6, then this will be the graph of this function y equals to x to the power 6. Okay, this is your graph of y equals to x to the power 6 and all these graphs will have similar nature. Okay, all these will start from x minus infinity, y plus infinity, x plus infinity, y plus infinity. Okay, now again if you want to draw the graph of say y equals to x to the power 1 by 2, now here you have to first draw this y equals to x line. This was our y equals to x line, right? This will be our y equals to x line. Now if you want to draw the graph of these type of function x to the power 1 by 2 or y equals to x to the power 1 by 4, then first thing, all these functions are defined only when x is positive. Okay, if x is any negative number, then value of y will become imaginary. Okay, value of y will be complex. Suppose if x is minus 2, then we all know that minus 2 to the power 1 by 2 is an imaginary number root 2 iota. Okay, so these functions are defined only when x is positive and therefore the graph of these type of function will be only in first quadrant, not in second quadrant. So if you want to draw the graph of say this function x to the power 1 by 2, then take the image of this graph of y equals to x square. Okay, this was our graph of y equals to x square. So you have to take the image of this function, okay, this graph in the line y equals to x. So the image will be something like this will be the image of that given function. So this means this is your graph of y equals to x to the power 1 by 2. Similarly, if you want the graph of x to the power 1 by 4, then take the image of graph of x to the power 4 in this y equals to x line. Okay, so this is how we draw the graph of this function x to the power 1 by n, where n is any positive integer, and we also have learned how to draw the graph of y equals to x to the power 1 by n, again n any positive integer. If it was odd number, then we have seen in our earlier case how to draw the graph. For even number, we have just learned how to draw this type of graph. So this was second important graph. The first one was y equals to mx. Then second one is graph of x to the power n, where n is any positive integer. Now the third case is graph of exponential function. So now we are going to learn how to draw the graph of these type of function. First of all, let me explain how this exponential function is defined. Exponential function is defined in this manner: y equals to a to the power x. A is any positive number and a is not equal to 1. If a is 1, then y equals to 1, this will become a constant function. And if a is any negative number, then a to the power x will not be always defined, meaning that suppose if base is minus 2, then minus 2 to the power x. Now this will not be defined whenever x is say 1 by 2, 1 by 4. So then it will not be a continuous function or defined for all the values of x. So if I define the function in this manner, y equals to a to the power x, and a is a positive number, then it will be defined for all the values of x. So in order to draw the graph of exponential function, we have to consider two different cases. The first case is when this base is more than 1. Okay, so whenever base is more than 1, for example, suppose if I want to draw the graph of say y equals to 2 to the power x. So how to draw the graph of this function? So when base is more than 1, then the graph will be, let me divide this into two parts. We'll consider two different cases. First case will be when base is more than 1. Second case will be when base is between 0 and 1. Okay. So here we will see how to draw the graph of this function y equals to, say base is 1 by 2, so 1 by 2 to the power x. So suppose if I want to draw the graph of this function, then first of all, whatever be the value of x, our y is always going to be positive, right? Even if x is negative, 2 to the power x will be positive. Say if x is minus 2, y will be 2 to the power minus 2, which is 1 by 2 to the power 2. So for all the value of x, y is always positive. Graph will be in first and second quadrant. Now you can see that when x is 0, then what is the value of y? The value of y is 1. When x is 1, then what is the value of y? 2. So this point will be x1, y2. I'm drawing the graph from this very basic concept. Take different values of x, take the corresponding value of y, plot the point, join those points. Similarly, when x is 2, then what is the value of y? If x is 2, y will be 4. So x 1 unit increased, y 2 units increased. So you will get a point here. Now you can see what will happen when x is 3. When x is 3, y will be 8. When x is 4, y will be 16. So these will be the points on this curve. And when x is minus infinity, then you can see that y will be 2 to the power minus infinity, which is 1 by 2 to the power infinity, 1 by infinity 0. So when x is minus infinity, y will be very close to 0. So your graph will start from x minus infinity, y 0, and as you increase the value of x, the value of y will keep on increasing. So this will be your graph of y equals to 2 to the power x. You can also apply the concept of derivative here. We all know that if first derivative for a function is positive, then function is increasing function. So here if you calculate the first derivative, then dy by dx will be 2 to the power x into log 2. Now we all know that log 2 is a positive number, 0.693. 2 to the power x is always positive. So this means here the first derivative dy by dx is positive for all x, and this implies that y is always an increasing function. So whenever base is more than 1, then the graph of this function will be increasing function. Okay. So graph of 2 to the power x, 3 to the power x, all will have similar nature. It will always cross through this point 0, 1, x minus infinity, y 0, and it will keep on increasing. And remember that after this graph is approaching towards y axis. Okay, when we learn the graph of log x, then we will be in a position to appreciate the difference between these two functions. So this will be the graph of function a to the power x when a is more than 1. Now we are going to see what happens when a is between 0 and 1. So let us see the graph of this y equals to 1 by 2 to the power x. Again, these are our coordinate axes. For all the value of x, y is always positive. No portion of the graph should be in third and fourth quadrant. Now, as you can see that if I place x equals to 0 here, if I place x equals to 0 here, then the value of y will be 1. So this means this